anytime.
Hi, this is Rich with InsideHPC. We're here at the Intel HPC Developer Conference in Salt Lake City, and I'm here with Prabhat from NERSC. How are you doing this afternoon,
Good,
sir?
Rich. Thanks for having me.
Good. Well, it's great to be here at SC16 now. I'll be starting up here. But you gave a talk today. I was wondering if you could tell us how that went.
Sure. The talk went well. I mean, there's a lot of interesting feedback from the audience. The talk was on one of the most scalable implementation of something called the KNearest neighbor algorithm. So it's a baseline implementation, a baseline machine learning technique that's used in practice.
Okay. And are you trying to get that to scale to thousands of cores? Is that the end game or what?
Absolutely. So we already have that scaling. So we have it applied to 100 billion points data sets, and it's running on 50,000 cores at the moment. Okay. And we think that we can scale it on even bigger machines.
Okay. And I wanted to ask you about the Intel technologies. How did they help you with getting that remarkable scaling?
Sure. So the hardware that we ran this on was, of course, Intel hardware. So there's a machine called Edison at NERSC, and that has the Xeon family of products. Mm-hmm. And the reason that we are able to create the KD tree in 48 seconds and query it in 12 seconds is because we are utilizing Intel hardware. So certainly I think hardware is key for both scaling and performance on a single node.
Okay. And when we talk about machine learning, we often talk about the two sides, right? The training and the inference. Which side was this problem?
So this was for both. So there's a step where you train or create the KT tree, and then there is the test side wherein you query the KT tree. And both of these right now, we've created the KT tree for a data set with 200 billion points in 48 seconds, and the test side, the query side, takes about 12 seconds on a similar number of cores.
Yeah. Well, this is exciting to hear about machine learning at this kind of scale, because there aren't that many machines in the world with that capability. So
absolutely. So I think NERSC is unique in that sense, in that we not only do we have the hardware, but we have interesting science problems from. I mean, what I talked about today featured science data sets from cosmology, particle physics, diabate detector. It's complex scientific data. It's large-scale data. But we have the methods in place now and the machines to load these data sets on, so we can actually do this analytics in less than a minute.
Yeah. So Prabhat, kind of a wrap-up question here. It seems like this is the SC about AI all of a sudden, and machine learning seems to be the hot topic. Are these worlds in the HPC world? You seeing more and more of these deep learning kind of and machine learning techniques being used?
Yeah, definitely. So it's picking up. I think we are slowly appreciating and understanding where the frontier really is. And frankly, I think the results that we are seeing in the commercial space are just far out there. So I think a number of scientists, myself at NERSC, we all now understand that entire classes of problems, classification, regression, they're all solvable. So we are definitely at NERSC, at least we are at the frontier of applying deep learning methods to scientific problems. And I think it's just the beginning of AI applied to science. The future is going to be very exciting.